Step 5 is to evaluate Newton's second law in terms of the free body diagram and the coordinate system that we have here. And so let's go ahead and do that real quick. So this is going to be our step 5. This is kind of it's a continuation of step 4. So I'm going to write step 5 right here, and then we'll see exactly how this is going to work. So when we're looking at our sum of forces in the x direction, what we're going to have to do is we need to consider the fact that our force of gravity here is actually going to have components that are going to be along the x direction and components that are going to be along the y direction. And so what that means here is we can include some components that are going to be in the this is going to be the y direction, this is the x direction, and ultimately this is going to be the angle of theta. And so what this says is that this portion of this line right here is going to say that this is going to be fg times cosine of theta, and this is going to be fg times sine of theta. This is going to be pointing this way, this is going to be pointing that way in order to make this a full vector. And so when we're looking at our sum of forces in the x direction, remembering that we chose down the inclined plane to be the positive direction, this says that our sum of forces in the x direction is going to be equal to Fg, which is in this case just mg, times sine of theta, minus the force of friction, because the force of friction is going to be pointing in the direction that we defined to be negative. And this is our sum of forces in the x direction. Now let's look at our sum of forces in the y direction. So when we're looking at our sum of forces in the y direction, what we see is we have our normal force is going to point in the positive y direction. We have a component of the force of gravity that's going to be pointing in the minus y direction. This is going to be minus mg times cosine of theta.